Have you ever used a web app that just felt fast? Incredibly responsive, almost like it's reading your mind? Well, there's a really good chance it was built with React. Today, we're going to pull back the curtain and solve one of the biggest mysteries in web development. What is React's secret to performance?
So yeah, what is the secret sauce here? How does React manage to update what you see on the screen so incredibly quickly, creating that smooth, seamless experience we all love? That's the core question we're diving into right now.
And spoiler alert, it isn't magic. It's actually a brilliant piece of engineering, a super clever concept at the very heart of the library called the virtual DOM. And this is the key that unlocks pretty much all of React's incredible performance. But, before we can really appreciate the solution, we have to understand the problem it was built to solve. And that problem, it lies deep within the browser itself. It's a fundamental challenge for all modern web apps.
Okay, so every time you load a web page, the browser builds this thing called the Document Object Model, or the DOM for short. Just think of it as a live, tree-like structure of everything on the page. It literally is the user interface. But here's the catch. Directly changing this real DOM is, well, it's slow. Every little change can force the browser to do these expensive recalculations, which can grind the whole user experience to a halt. And this is where React's solution comes into play. On one hand, you've got the real DOM. It's slow, it's costly to update. On the other hand, React introduces its own answer, the virtual DOM. It's this super fast, lightweight copy, a blueprint that only exists in memory, not on the actual screen.
So let's get into what this secret blueprint actually is and how it gives React its superpower. This really is the heart of the whole concept.
At its core, the virtual DOM is pretty much what it sounds like, a virtual representation of the UI, kept in memory and totally in sync with the real DOM. But because it's just a plain JavaScript object, it is unbelievably fast to mess with. There are no browser recalculations, no screen repaints, just pure, fast data manipulation. Which, of course, leads to the obvious question, right? If it's just a copy, how in the world does that actually speed anything up? I mean, the real UI still has to be changed eventually.
The answer lies in this brilliant process that React uses called reconciliation, and it involves this clever spot the difference game that we call diffing.
Let's walk through this. First, something happens. Let's say a user clicks a button. In response, React doesn't even touch the real screen. Instead, it builds a brand new virtual DOM that shows what the UI should look like now. Then, and this is the crucial part, it compares the new virtual DOM with the old one. It finds the absolute tiniest difference between them. Finally, it takes only that tiny specific change and applies it to the slow, real DOM.
And that comparison process, that spot the difference game I mentioned, it has a name, diffing. React's diffing algorithm is like a detective that figures out exactly what changed, making sure that the slow, real DOM is touched as little as humanly possible.
But even this super clever detective work can be made even better. React has a special tool in its belt to make its diffing algorithm even smarter and faster, especially when you're dealing with lists of items.
And that tool is keys. Keys give each element in a list a unique, stable identity. You can think of it like a name tag for each item. With this tag, React no longer has to guess what changed, it knows for sure.
And the difference is dramatic. I mean, without keys, if you reorder a list, React might get confused and just destroy the whole list to rebuild it in the new order, which is a huge performance hit. But with keys, React sees those name tags and just goes, oh, these are the same items. They've just moved around. The update becomes tiny and performance is saved. It's a huge deal.
All right, we have one final crucial piece of this performance puzzle to reveal. What happens when a ton of things change all at once?
So just imagine a user is interacting with your app really quickly. They click a button, they type something into a form, maybe some data loads in the background, all happening within a fraction of a second. Each one of those is a state change.
Now, the simple, naive approach would be to update the real DOM 3 separate times, right? Which would be slow and really inefficient. But React is way smarter than that. It sees these rapid-fire changes and basically says, whoa, hold on a second, and decides to wait just a tiny moment, grouping them all together.
And then it bundles all those changes and performs just one single, efficient update to the real DOM. So you had 3 actions, multiple virtual DOM comparisons, but only one expensive write to the screen. This is called batching, and it is an absolute game changer for performance.
So let's put it all together. The problem: the real DOM is slow. React's solution: a fast in-memory blueprint called the virtual DOM.
Its method, a clever process of reconciliation and diffing to find the absolute minimum change needed. And its secret weapons, keys for stable identity, and batching for crazy efficiency. That is the secret to React speed.
So, we've demystified the magic. Now that you're in on the secret and you understand all this invisible work happening behind that smooth UI, it kind of makes you wonder, right? What other brilliant hidden engineering solutions are out there, quietly making our digital lives better? Thanks for joining me.